A system is a set of interacting or interdependent component parts forming a complex, intricate whole. Every system is delineated by its spatial and temporal boundaries, surrounded and influenced by its environment, described by its structure and purpose, and expressed in its functioning. The term system may also refer to a set of rules that governs structure and/or behavior. Alternatively, and usually in the context of complex social systems, the term is used to describe the set of rules that govern structure and/or behavior. Etymology. The term system comes from the Latin word systema, in turn from Greek sigma upsilon sigma tau eta mu alpha systema, whole compounded of several parts or members. System, literary composition. History. According to Marshall McLuhan, system means something to look at. You must have a very high visual gradient to have systematization. In philosophy, before Descartes, there was no system. Plato had no system. Aristotle had no system. In the 19th century, the French physicist Nicolas Léonard Sadi-Carnot, who studied thermodynamics, pioneered the development of the concept of a system in the natural sciences. In 1824 he studied the system which he called the working substance in steam engines. In regards to the system's ability to do work when heat is applied to it, the working substance could be put in contact with either a boiler, a cold reservoir, or a piston. In 1850, the German physicist Rudolf Clausius generalized this picture to include the concept of the surroundings and began to use the term working body when referring to the system. The biologist Ludwig von Bertalanffy became one of the pioneers of the general systems theory. In 1945 he introduced models, principles, and laws that apply to generalized systems or their subclasses, irrespective of their particular kind, the nature of their component elements, and the relation or forces between them. Norbert Wiener and Ross Ashby, who pioneered the use of mathematics to study systems, carried out significant development in the concept of a system. In the 1980s, John H. Holland, Murray Gell-Mann and others coined the term complex adaptive system at the interdisciplinary Santa Fe Institute. System concepts. Environment and boundaries. Systems theory views the world as a complex system of interconnected parts. We then make simplified representations of the system in order to understand it and to predict or impact its future behavior. These models may define the structure and/or the behavior of the system. Natural and human-made systems. There are natural and human-made systems. Natural systems may not have an apparent objective, but their outputs can be interpreted as purposes. Human-made systems are made with purposes that are achieved by the delivery of outputs. Their parts must be related, they must be designed to work as a coherent entity, else they would be two or more distinct systems. Theoretical framework. An open system exchanges matter and energy with its surroundings. Most systems are open systems, like a car, coffee maker, or computer. A closed system exchanges energy, but not matter, with its environment, like Earth or the project Biosphere 2 or 3. An isolated system exchanges neither matter nor energy with its environment. A theoretical example of such system is the universe. Process and transformation. Process. An open system can also be viewed as a bounded transformation process, that is, a black box that is a process or collection of processes that transforms inputs into outputs. Inputs are consumed, outputs are produced. The concept of input and output here is very broad. E.g., an output of a passenger ship is the movement of people from departure to destination. Subsystem. A subsystem is a set of elements, which is a system itself, and a component of a larger system. System model. A system comprises multiple views. For the man-made systems it may be such views as concept, analysis, design, implementation, deployment, structure, behavior, input data, and output data views. A system model is required to describe and represent all these multiple views. Systems architecture. A systems architecture, using one single integrated model for the description of multiple views such as concept, analysis, design, implementation, deployment, structure, behavior, input data, and output data views, is a kind of system model. Analysis of systems. Evidently, there are many types of systems that can be analyzed both quantitatively and qualitatively. For example, with an analysis of urban systems dynamics, A.W. Stice defines 5 intersecting systems, including the physical subsystem and behavioral system. For sociological models influenced by systems theory, where Kenneth D. Bailey defines systems in terms of conceptual, concrete and abstract systems, either isolated, closed, or open. Walter F. Buckley defines social systems in sociology in terms of mechanical, organic, and process models. Bella H. Banathy cautions that with any inquiry into a system, that understanding the type of system is crucial, and defines natural and designed systems. Systems that are purposed by man inherently have a major flaw. They must have a starting assumption in which this starting assumption is used to build further knowledge upon. This starting assumption is not inherently bad, but it is used as the foundation of the system, and as it is assumed to be true, and not definitively so, then the system is not as structurally sound as perceived to be. For example, in geometry this is highly evident when one goes through the process of taking theorems and extrapolates proofs from those set theorems. In offering these more global definitions, the author maintains that it is important not to confuse one for the other. The theorist explains that natural systems include subatomic systems, living systems, the solar system, the galactic system and the universe. The human element of organization and activities are emphasized with their relevant abstract systems and representations. A key consideration in making distinctions among various types of systems is to determine how much freedom the system has to select purpose, goals, methods, tools, etc., and how widely is the freedom to select itself distributed in the system. George J. Klir maintains that no classification is complete and perfect for all purposes, and defines systems in terms of abstract, real, and conceptual physical systems, bounded and unbounded systems, discrete to continuous, pulse to hybrid systems, etc. The interaction between systems and their environments are categorized in terms of relatively closed and open systems. It seems most unlikely that an absolutely closed system can exist, or, if it did, that it could be known by us. Important distinctions have also been made between hard and soft systems. Hard systems are technical in nature and amenable to methods such as systems engineering, operations research and quantitative systems analysis. Soft systems involve people and organizations and are commonly associated with concepts developed by Peter Checklin and Brian Wilson through soft systems methodology, involving methods such as action research and emphasizing participatory designs. Where hard systems might be identified as more scientific, the distinction between them is actually often hard to define. Cultural system. A cultural system may be defined as the interaction of different elements of culture. While a cultural system is quite different from a social system, sometimes both systems together are referred to as the socio-cultural system. A major concern in the social sciences is the problem of order. Economic system. An economic system is a mechanism which deals with the production, distribution and consumption of goods and services in a particular society. The economic system is composed of people, institutions and their relationships to resources, such as the convention of property. It addresses the problems of economics, like the allocation and scarcity of resources. Application of the system concept. Systems modeling is generally a basic principle in engineering and in social sciences. The system is the representation of the entities under concern. Hence inclusion to or exclusion from system context is dependent of the intention of the modeler. No model of a system will include all features of the real system of concern, and no model of a system must include all entities belonging to a real system of concern. Systems in information and computer science. In computer science and information science, system is a software system which has components as its structure and observable inter-process communications as its behavior. Again, an example will illustrate. There are systems of counting, as with Roman numerals, and various systems for filing papers, or catalogs, and various library systems, of which the Dewey Decimal System is an example. This still fits with the definition of components which are connected together. System can also be used referring to a framework, be it software or hardware, designed to allow software programs to run. See platform. Systems in engineering and physics. In engineering and physics, a physical system is the portion of the universe that is being studied. Engineering also has the concept of a system that refers to all of the parts and interactions between parts of a complex project. Systems engineering refers to the branch of engineering that studies how this type of system should be planned, designed, implemented, built, and maintained. Systems in social and cognitive sciences and management research. Social and cognitive sciences recognize systems in human person models and in human societies. They include human brain functions and human mental processes, as well as normative ethics systems and social, cultural behavioral patterns. In management science, operations research and organizational development, human organizations are viewed as systems of interacting components such as subsystems or system aggregates, which are carriers of numerous complex business processes and organizational structures. Organizational development theorist Peter Senge developed the notion of organizations as systems in his book The Fifth Discipline. Systems thinking is a style of thinking, reasoning and problem-solving. It starts from the recognition of system properties in a given problem. It can be a leadership competency. Some people can think globally while acting locally. Such people consider the potential consequences of their decisions on other parts of larger systems. This is also a basis of systemic coaching in psychology. Organizational theorists such as Margaret Wheatley have also described the workings of organizational systems in new metaphoric contexts, such as quantum physics, chaos theory, and the self-organization of systems. Pure logical systems. There is also such a thing as a logical system. The most obvious example is the calculus, developed simultaneously by Leibniz and Isaac Newton. Another example is George Boole's Boolean operators. Other examples have related specifically to philosophy, biology, or cognitive science. Maslow's hierarchy of needs applies psychology to biology by using pure logic. Disambiguation needed. Numerous psychologists, including Carl Jung and Sigmund Freud, have developed systems which logically organize psychological domains, such as personalities, motivations, or intellect and desire. Often these domains consist of general categories following a corollary such as a theorem. Logic has been applied to categories such as taxonomy, ontology, assessment, disambiguation needed, and hierarchies. Systems applied to strategic thinking. In 1988, military strategist John A. Warden III introduced his 5-ring system model in his book, The Air Campaign, contending that any complex system could be broken down into 5 concentric rings. Each ring, leadership, processes, infrastructure, population and action units, could be used to isolate key elements of any system that needed change. The model was used effectively by Air Force planners in the First Gulf War. In the late 1990s, Warden applied this 5-ring model to business strategy. Bibliography: Alexander Backlund. The Definition of System. In Kybernetis Volume 29 near 4, pp. 444-451. Kenneth D. Bailey. Sociology and the New Systems Theory. Toward a Theoretical Synthesis. New York, State of New York Press. Bella H. Banathy. A Taste of Systemics, ISSS The Primer Project. Walter F. Buckley. Sociology and Modern Systems Theory, New Jersey. Englewood Cliffs. Peter Checkland. Systems Thinking, Systems Practice. Chichester. John Wiley & Sons, Limited. Michel Crozier, Erhard Friedberg. Actors and Systems, Chicago University Press. Robert L. Flood. Rethinking the Fifth Discipline. Learning Within the Unknowable. London. Routledge. George J. KLIR. Approach to General Systems Theory, 1969. Brian Wilson. Systems, Concepts, Methodologies and Applications. John Wiley. Brian Wilson. Soft Systems Methodology, Conceptual Model Building and Its Contribution. J. H. Wiley. Bain on Davies P. Business Information Plus Systems. Palgrave, Basingstoke. ISBN 978-0-230-20368-6.